Welcome to the next scale model, 1 to a quintillion. We're 1,000 times more than 1 to a quadrillion, which was our previous scale model. And this one we'll call exa, from Greek, meaning 6. So 1,000 to the 6th power is quintillion. And previously we couldn't really accommodate the galaxy. Stars were still very far apart. Alpha Centauri to the Sun was 40 meters. But at this scale, we're 1,000 times closer, right? So we're at about 4 centimeters away. Stars now are a lot closer to each other, but they're just filled all around us. So it's a really fun scale model to look at. As you walk through it, it's probably like swimming in the stars. And the Milky Way is about 1 kilometer edge to edge. Right now we're kind of sitting on the outer rim, and the lighthouse is about 500 meters away, so that's about the center. We can pretend that's the center of the Milky Way. So I'm about 10 meters away right now, at about 1,000 light years from where the camera is at. And this local area here is where we could see stars with the naked eye. And for thousands of years, that's all we had was the naked eye. We didn't have telescopes yet. If I went much further than this, all the stars basically start looking like a white milky glow. And that was the reason why we call it the Milky Way. So the closer stars are the ones that we've been tracking. The rising and the setting and the discovery of astronomy was all done with local stars. And this changed with the invention of the telescope. We realized that the stars go much further out. Galileo looked at star clusters and areas along the Milky Way and realized they were made of stars. They were just very, very distant stars. And so it dawned on everybody that the Milky Way is this kind of large pancake of swirling mass made up of mainly of stars. And embedded in there were also a lot of fuzzy objects. They weren't sure what they were. They were called nebulae. So William Herschel cataloged thousands of these nebulae that were lying within the Milky Way, or at least that's what they thought at the time. A lot of these nebulae turned out were separate galaxies, but back then they didn't know that. So they just thought the Milky Way was the entire universe, about 100,000 light years across. And at this scale, a light year is about 1 centimeter, right? So it takes light about that long to cross this gap. So here to the lighthouse, it's a little under 500 meters, but that would around 50,000 years, and then to the other edge of the Milky Way, another 50,000, so diameter of about 100,000 light years across. And probably to the people back then, that was considered already a vast place. And it wasn't later that in 1924, as telescopes got better and as we took more measurements, where Edwin Hubble realized that the Milky Way is just one tiny little player in the entire cosmos. All these nebulae which had been cataloged, or many of them, turned out were separate galaxies, and they weren't in the Milky Way. They're actually far, far outside. And at this scale model, we can't really accommodate that. We have to basically jump to our next scale model. So I'll see you in that one.